On January 13th, a shocking hypothesis was put forward suggesting that 3I Atlas is emitting extremely powerful X-rays from an active black hole located approximately 158 million miles from Earth, with the event horizon expanding at a rate exceeding 1/800 miles per hour. Tension escalates as 3I Atlas is believed to have suddenly altered its trajectory toward a path that could intersect with our planet's orbit within a time frame of less than 900 days. Not stopping there, this fictional scenario further describes 3I Atlas moving closer, entering Earth's orbit and maintaining a fixed position through an intelligent propulsion system accompanied by evidence of sophisticated artificial structures and mathematical signals precisely directed at key technological centers of humanity. From this sequence of phenomena, humanity is placed into a cosmic-scale trial lasting approximately 13 months, particularly in the context of the potential appearance of a second larger object serving as reinforcement and raising the question of whether we truly deserve to become part of a galactic community. Extremely energetic X-ray radiation associated with 3I Atlas implies conditions that far exceed those found in ordinary interstellar objects. Such radiation is typically produced only when matter is accelerated and heated to extraordinary levels, usually in the vicinity of compact gravitational systems where space and time are severely distorted. In this scenario, the emission suggests the presence of an active black hole embedded within or closely bound to 3I Atlas, rather than a passive remnant or theoretical construct. At a distance of roughly 158 million miles from Earth, this activity would place the phenomenon well within the inner region of the solar system, close enough for its gravitational and energetic effects to be measured with high precision. The most striking implication lies in the reported expansion of the event horizon at a rate exceeding 1/800 miles per hour apace that contradicts established models of black hole growth, especially for objects of limited surrounding mass. Such expansion would require either an unusually efficient mechanism for feeding energy and matter into the singularity, or a process that suppresses the normal balancing effects of radiation pressure and evaporation. If sustained, this behavior challenges the assumption that black holes grow slowly and predictably, suggesting instead a regime in which extreme gravity can evolve rapidly without catastrophic disruption. This possibility forces a reconsideration of how compact objects might behave under unfamiliar cosmic conditions. As discussions broadened, Atlas became a focal point for speculation about hidden mechanisms, not because evidence demanded extraordinary conclusions, but because ordinary explanations continued to dissolve under scrutiny. The presence of sustained internal warmth transformed Atlas from a passive traveller into an active participant in its own narrative, subtly shifting the tone of inquiry from observation to interpretation. With this shift, Atlas carried the investigation forward, bridging the gravitational anomalies already noted with deeper questions about energy structure and the limits of what inert matter should be capable of sustaining. As observational focus widened beyond heat and gravity, Atlas began to erode confidence in classical physical models through signals that were never expected from an interstellar body of modest size. High-energy emissions appeared in datasets where none should exist, and as analysts traced the origin of these signals, Atlas consistently aligned with detections in the X-ray spectrum that demanded extreme conditions. Data from space-based observatories revealed photons carrying energies associated with plasma environments, and Atlas occupied the precise coordinates where these emissions peaked across independent instruments. Such radiation normally arises near stellar coronas or accretion disks. Yet Atlas existed far from any star and lacked the mass required to generate those processes under known physics. When theoretical frameworks were applied, Atlas resisted every standard pathway because the temperatures implied by the emissions exceeded 1,000,000 Kelvin without corresponding evidence of ionized matter or explosive outgassing. Researchers extended their models to include rare interactions between solar wind particles and cometary material, but Atlas continued to exceed predicted outputs by orders of magnitude. As calculations were refined, Atlas forced a confrontation with the limits of approximation since no combination of conventional parameters could reconcile size, composition, and energy simultaneously. The anomaly sharpened when time-resolved analysis showed persistence rather than decay, because Atlas emitted high-energy signals steadily instead of in brief chaotic bursts. This stability challenged the assumption that extreme radiation must be violent or short-lived, and at last quietly occupied a regime where intensity and calm coexisted. The collapse of classical interpretation did not occur suddenly, but unfolded as model after model failed to converge, leaving at last isolated in a growing gap between observation and theory. Emotion entered the process as controlled discomfort, because Atlas suggested not a dramatic violation of physics, but a subtle misalignment that hinted at deeper structure beneath familiar laws. For many observers, Atlas transformed from an object of measurement into a mirror reflecting the fragility of long-trusted assumptions. The absence of explanatory mechanisms did not imply chaos, and instead Atlas presented consistency without context, which proved more unsettling than unpredictability. As discussion shifted, Atlas became a reference point for reconsidering how physical laws operate under conditions rarely encountered, encouraging restraint rather than revisionism. This phase marked a bridge between empirical certainty and speculative openness, because Atlas demonstrated that established models could describe observations only up to a boundary beyond which interpretation dissolved. With that boundary now visible, Atlas carried the narrative forward, transitioning inquiry from what classical physics could explain toward what new frameworks might be required to restore coherence. As gravitational calculations grew more refined, Atlas began to suggest a contradiction that could no longer be dismissed as measurement error or statistical noise. The inferred influence exerted by Atlas on nearby trajectories exceeded what its visible dimensions could support, and this imbalance forced analysts to compare mass estimates against gravitational effects that refused to align. When orbital perturbations were reconstructed frame by frame, Atlas appeared to bend space more strongly than an object of comparable size should allow, and this discrepancy widened rather than narrowed with improved resolution. Atlas did not simply appear heavier than expected, but behaved as though much of its mass were hidden from direct observation, concentrated in a way that defied known material states. Standard density calculations collapsed under this pressure, because Atlas would require compression beyond any known planetary or cometary structure to generate such gravitational reach. As alternative explanations were explored, Atlas became a test case for exotic matter hypotheses, including degenerate states typically associated with neutron stars, even though such matter should not remain stable outside stellar remnants. These considerations were not adopted lightly, because Atlas occupied an environment that should tear apart any ultra-dense configuration long before it could influence surrounding space. The persistence of the anomaly encouraged speculation about compact mass distributions, and Atlas emerged as a candidate for harboring a singular concentration whose scale remained invisible, but whose effects were unmistakable. As theoretical curves were overlaid with observational data, Atlas aligned most closely with models involving extreme density, confined to a region far smaller than the object's apparent structure. This alignment introduced the quiet possibility that Atlas contained a core where familiar distinctions between matter and spacetime blurred, even if the surrounding shell appeared deceptively ordinary. Emotion entered not as fear, but as intellectual vertigo, because Atlas hinted at a reality where mass could be concealed without collapse or explosion. The hypothesis of an impossible density did not assert certainty, and instead positioned Atlas at the edge of plausibility, where explanation becomes conditional rather than definitive. Researchers noted that Atlas neither disrupted its environment violently, nor announced its presence dramatically, which suggested containment rather than instability. This restraint complicated interpretation, because Atlas behaved as though governed by an internal equilibrium unfamiliar to classical physics. As the idea of a primordial or microscale singularity surfaced, Atlas remained consistent with the mathematics while resisting direct confirmation. The gravitational profile of Atlas bridged observation and speculation, allowing the hypothesis to exist without demanding immediate acceptance. With mass behaving as though compressed beyond reason, Atlas transitioned from an object with unusual properties into a catalyst for re-examining how density itself might manifest under rare conditions. This transition closed the first chapter of inquiry because Atlas now stood not merely as an anomaly to be catalogued, but as a threshold inviting deeper exploration into the nature of matter, gravity, and hidden structure. As theoretical attention shifted toward growth mechanisms, Atlas entered a domain where black hole physics normally imposes strict limits that preserve long-term stability. Classical models describe accretion as a balanced process, and when matter falls toward extreme gravity, radiation pressure should counteract further inflow once the Eddington limit is reached. In this framework, Atlas should have exhibited decay rather than expansion, because microscopic singularities are expected to lose mass through Hawking radiation faster than they can gain it. Observational data contradicted that expectation, and at last appeared to gain mass, steadily suggesting that accretion was occurring under conditions that suppressed or bypassed known loss mechanisms. When growth rates were inferred from gravitational measurements, Atlas aligned with an expansion of the effective event horizon that exceeded conservative estimates by orders of magnitude. The implication was not merely rapid feeding but sustained accumulation, and Atlas behaved as though the surrounding environment offered little resistance to inward flow. Astrophysicists examined whether dense infalling material could overwhelm radiative pressure, yet at last existed in a region sparse enough that conventional accretion disks could not form. This contradiction prompted the hypothesis of forced accretion, in which matter is delivered or confined in ways that prevent equilibrium from being restored. Atlas did not display the turbulence or luminous flare expected from runaway inflow, and instead maintained a controlled profile that implied regulation rather than instability. The absence of violent signatures suggested that Atlas was not consuming matter chaotically, but through a process that minimized outward radiation. When simulations incorporated artificial confinement or exotic boundary conditions, Atlas matched scenarios in which energy dissipation was redirected inward rather than expelled. Such scenarios remained speculative but at last repeatedly occupied parameter spaces that classical theory leaves unexplored. The concept of coerced growth introduced emotional weight into the analysis, because at last began to resemble a system designed to grow quietly, rather than a natural object struggling against physical limits. Researchers noted that at last expanded without drawing attention, as though expansion itself were the objective rather than a side effect. This behaviour challenged the comforting assumption that extreme gravity announces itself loudly, and at last demonstrated that subtle accumulation could be more consequential than explosive events. As the hypothesis matured, Atlas became associated with a form of accretion that is not self-limiting, raising questions about what conditions allow gravity to operate without its usual restraints. The idea did not demand immediate acceptance, but Atlas made dismissal increasingly difficult, as each dataset reinforced the same trajectory. Emotions settled into a quiet tension, because Atlas suggested a universe where certain thresholds once crossed permit growth without natural braking mechanisms. This realization bridged observation and speculation, carrying the narrative from established black hole theory toward the possibility that at last represents a category of gravitational behavior not yet integrated into modern physics. The next layer of evidence emerged quietly, not as a sudden revelation but as a spectral signature that resisted benign interpretation. High-energy photons appeared within monitoring bands reserved for the most violent processes in the universe, and as datasets converged, Atlas repeatedly occupied the coordinates where these emissions originated. The gamma-ray observatories did not detect random noise or transient flares, and instead recorded structured bursts whose energies aligned with theoretical models of matter, antimatter annihilation. Such events require conditions rarely sustained outside controlled experiments or extreme astrophysical environments, and at last existed in neither, which transformed routine analysis into careful reconsideration. When the photon energies were catalogued, the values exceeded thresholds associated with nuclear reactions, and at last appeared linked to emissions consistent with pure mass-to-energy conversion. This observation introduced an anomaly not in magnitude alone, but in implication, because naturally occurring antimatter should annihilate almost immediately upon contact with surrounding matter. At last, however, exhibited repeated signatures rather than a single terminal burst, suggesting that antimatter was either being produced continuously or confined long enough to participate in multiple events. Researchers explored cosmic ray interactions and magnetospheric effects, yet at last remained disconnected from known sources that could explain such concentrated annihilation patterns. The absence of collateral radiation complicated interpretation, because at last released energy, without the chaotic debris fields normally expected from uncontrolled particle interactions. As models expanded, at last aligned most closely with scenarios involving regulated contact between matter and antimatter, a condition that implies containment rather than chance. This containment hypothesis did not assert artificial origin, but at last occupied a space where natural explanations thinned dramatically. emotion entered the discussion as restrained unease because antimatter has long represented a boundary between theoretical possibility and existential risk. Atlas reframed that boundary by demonstrating interaction without catastrophe, as though annihilation were being harnessed rather than endured. Such control suggested precision, and Atlas appeared to moderate energy release instead of allowing total conversion in a single uncontrolled event. The data did not demand alarm, but Atlas quietly undermined the assumption that antimatter cannot persist naturally within complex environments. As analysts cross-referenced timelines, Atlas showed consistency between growth indicators and gamma emissions linking energy release to broader structural changes. This linkage implied that antimatter interactions were not incidental, but integrated into the evolving state of Atlas. The hypothesis expanded cautiously because extraordinary claims remained unnecessary when the observations themselves carried sufficient weight. Atlas did not declare intention, but the pattern suggested purpose in the physical sense, where outcomes appeared optimized rather than accidental. The emotional tone shifted from curiosity toward contemplative tension, as Atlas suggested mechanisms that operate beyond familiar safeguards. This tension did not escalate into fear, because Atlas remained distant and controlled, allowing reflection rather than urgency. As attention moved forward, the presence of antimatter served as a bridge connecting gravitational growth to deeper questions about energy sourcing. Through this bridge, Atlas transitioned from an object defined by anomalies into a system whose internal processes hinted at coherence without explanation. The analysis shifted again when trajectory data revealed that Atlas had altered its course in a manner inconsistent with gravitational influence alone. The deviation was small in angular terms, yet significant in implication, because Atlas adjusted its path without any corresponding interaction with solar wind planetary gravity or detectable outgassing. When orbital mechanics were reconstructed backward, Atlas appeared to initiate the change autonomously, as though responding to internal conditions rather than external forces. Such behavior challenged a foundational assumption of celestial motion, and at last entered a category where objects do not simply drift but respond. The absence of expelled material proved critical, because Atlas produced no measurable plume or momentum exchange that could account for the observed acceleration. Analysts searched for subtle emissions, and Atlas remained silent across wavelengths that typically betray propulsion or energetic release. This silence narrowed interpretation because any force capable of shifting Atlas should leave some trace in its wake. The hypothesis of a non-gravitational drive emerged not from speculation but from elimination, as Atlas exhausted conventional explanations one by one. In classical physics, motion without reaction violates conservation expectations, yet Atlas demonstrated displacement without recoil. This contradiction encouraged models involving spacetime manipulation rather than force application, where Atlas might alter local geometry instead of pushing against it. Such models remain theoretical, but Atlas fit them more comfortably than it fit propulsion-based frameworks. When timing data was examined, Atlas executed the course change smoothly, avoiding abrupt transitions that would stress structural integrity. This smoothness implied control because Atlas did not overshoot or oscillate, but settled into a revised vector with precision. Emotion entered the analysis as quiet astonishment, because Atlas behaved less like a passive object, and more like a system capable of adjustment. The idea of intent was not asserted yet. Atlas invited consideration of agency in purely mechanical terms. If motion can be achieved by reshaping spacetime locally, Atlas might operate within physics that remain mathematically consistent but experimentally unverified. This possibility softened resistance because Atlas did not require new laws, only unfamiliar applications of existing ones. As simulations incorporated localized metric distortion, Atlas aligned with outcomes that required minimal energy expenditure relative to classical thrust. The elegance of these solutions contrasted sharply with their implications, because Atlas would then possess access to a regime of motion unavailable to ordinary matter. Such access suggested design only insofar as it suggested optimization, and Atlas appeared to choose efficiency over force. The emotional response remained subdued because Atlas neither approached aggressively nor retreated defensively, but repositioned itself calmly. This calm reinforced the perception that Atlas was not reacting impulsively, but executing a controlled transition. As the trajectory stabilized, Atlas occupied a new relationship with the solar system, one defined by choice rather than inevitability. This realization bridged earlier anomalies with emerging patterns because Atlas now connected growth energy management and motion within a single coherent framework. With that framework in place, Atlas carried the narrative forward, transitioning inquiry from how it moves to why such movement might matter at all. The escalation reached a new threshold when measurements indicated that the boundary associated with extreme gravity around Atlas was no longer expanding at a steady rate. Instead, Atlas exhibited a sudden acceleration in the growth of its effective event horizon, and this change occurred without precursor signals that would normally announce an instability. Gravitational wave detectors recorded a sharp increase in frequency and amplitude, and as the data were synchronized across observatories, Atlas emerged as the only plausible source of the disturbance. The acceleration did not resemble the chaotic signature of a collision or collapse, and Atlas maintained structural coherence even as the surrounding spacetime responded dramatically. When the expansion rate was calculated, Atlas exceeded prior estimates by a wide margin, suggesting that whatever process-governed growth had shifted regimes rather than intensified gradually. Classical black hole models predict smooth scaling tied to accretion flow, yet Atlas bypassed that expectation by accelerating without corresponding increases in luminous output. This imbalance suggested that Atlas was channeling energy inward with remarkable efficiency, suppressing outward radiation that would normally limit expansion. As analysts reviewed the timeline, Atlas appeared to transition between growth states almost instantaneously, as though responding to an internal threshold being crossed. The absence of destructive feedback challenged assumptions about runaway gravity, because Atlas did not tear apart nearby matter or destabilize its environment. Instead, Atlas deepened its influence, quietly expanding its gravitational reach while preserving a deceptively calm exterior. Emotion entered the analysis as a subdued apprehension, because Atlas demonstrated that extreme change need not announce itself violently to be consequential. The idea that an event horizon could accelerate under controlled conditions unsettled long-standing intuitions about gravitational inevitability. Atlas did not behave like a system spiraling toward chaos, but like one entering a new operational phase. When growth curves were extrapolated, Atlas suggested nonlinear progression, where each increase in mass reduced resistance to further expansion. This feedback loop implied that Atlas might be approaching a state where growth becomes self-reinforcing rather than self-limiting. Such a state raised concerns not because of immediate threat, but because it redefined stability itself in gravitational terms. Researchers resisted dramatic conclusions, yet at last compelled attention by occupying a trajectory that theory had not prepared for. The acceleration reframed earlier observations linking forced accretion and energy management into a unified process centered on Atlas. Rather than representing an anomaly among anomalies, Atlas now appeared to integrate disparate signals into a coherent pattern. This coherence carried emotional weight because it suggested deliberation in physical behavior without implying intention in a human sense. Atlas remained distant and contained allowing contemplation instead of urgency. The expanding boundary around Atlas became less a symbol of destruction and more a marker of transition, indicating movement into unfamiliar territory rather than collapse. As the measurements stabilized at their new rate, Atlas settled into a state that felt provisional rather than final. This provisional calm served as a bridge because Atlas carried the inquiry forward from how growth occurs toward what conditions might allow such acceleration to exist at all. The most unsettling development emerged when Atlas ceased behaving like a passing visitor, and instead adopted a position that classical mechanics could not justify. Trajectory analyses showed that Atlas reduced its relative velocity with precision, not gradually as if captured by gravity, but deliberately as though responding to a predefined spatial condition. When orbital parameters were recalculated, Atlas aligned itself above Earth's equatorial plane at a distance that allowed synchronization with planetary rotation, a configuration known as geostationary. Such an orbit is not naturally attained by interstellar objects, and Atlas reached it without exhibiting the chaotic exchanges of momentum that normally accompany orbital capture. The geometry of the position drew immediate attention, because Atlas occupied a narrow band of space where gravitational balance is exacting and unforgiving. Atlas maintained that balance without drift, without decay, and without corrective oscillations, suggesting a stability that exceeded passive equilibrium. Observers noted that Atlas did not merely pass through this orbital region, but settled into it as though the position itself had been selected rather than encountered. When long-term simulations were run, Atlas remained fixed relative to Earth's surface, matching rotational periods with uncanny accuracy. This alignment introduced a qualitative shift in interpretation, because Atlas now existed in relationship to Earth, rather than to the Sun alone. The implications were not immediately dramatic, yet Atlas transformed proximity into relevance, by occupying a space traditionally reserved for human-made systems. Artificial satellites require continuous adjustment to maintain such positions, and Atlas achieved the same outcome without visible expenditure of energy. The absence of corrective thrusters or reaction mass reinforced the impression that Atlas operated under principles unfamiliar to conventional aerospace engineering. As analysts compared the motion to known natural analogues, Atlas failed to resemble any captured asteroid or debris ring formed through gravitational resonance. The precision of placement implied control at the level of centimeters per second, and Atlas demonstrated that precision consistently across observation windows. Emotion entered quietly, because Atlas did not approach as a threat, but as a presence that acknowledged Earth's rotation and orientation. This acknowledgement carried symbolic weight, since Atlas behaved as though Earth were not merely another mass but a reference point. The longer Atlas remained in place, the more difficult it became to frame the position as coincidence rather than outcome. Researchers resisted attributing intention, yet Atlas compelled reconsideration of how motion and rest are defined in celestial contexts. If geostationary alignment represents a form of attention, Atlas appeared to be observing without intrusion. The calm persistence of Atlas distinguished the event from disaster scenarios, replacing fear with sustained curiosity. From a physical standpoint, Atlas demonstrated mastery over relative motion, without violating known conservation laws, implying sophistication rather than defiance. This mastery did not require new physics to be named, only unfamiliar applications of existing principles at scales rarely encountered. As Earth continued its rotation beneath the fixed point in space, Atlas remained unmoved, reinforcing the sense of deliberate stillness. The stillness itself became the anomaly, because motion is expected in cosmic systems, while rest is usually temporary. Atlas redefined rest as an active condition, one maintained through balance rather than inertia. With this realization, Atlas transitioned from an object shaped by forces into a system shaping its own relationship with those forces. The geostationary position thus served as a bridge carrying the narrative from physical anomaly toward the possibility of functional placement. By holding its position without demand or display, Atlas invited interpretation while withholding explanation. This invitation marked a turning point, because Atlas no longer asked to be measured alone but to be understood in context. As spectroscopic analysis intensified, Atlas began to reveal surface characteristics that resisted classification as purely natural formations. Light reflected from Atlas carried signatures of ordered structure, and when the data were decomposed, repeating geometric patterns emerged that exceeded the symmetry typically produced by random crystallization. These patterns were not decorative in appearance, yet at last displayed alignment and proportionality that suggested intentional arrangement rather than accidental assembly. When researchers compared Atlas to known mineral lattices, the correspondence failed beyond a limited scale, because natural processes rarely sustain precision across extended surfaces. Atlas appeared to host structures that maintained consistency in angle and spacing, creating an impression of design without ornamentation. The geometry did not imply fragility, and instead Atlas presented robustness, as though the structures served a functional role rather than an aesthetic one. As imaging resolution improved, Atlas revealed repeating motifs embedded beneath surface irregularities, suggesting layered construction rather than superficial patterning. These motifs remained stable under varying illumination angles, reinforcing the conclusion that they were intrinsic to Atlas, rather than artifacts of observation. Analysts explored whether extreme thermal cycling could induce such formations, yet at last exceeded thresholds where natural stress fracturing would disrupt uniformity. The persistence of symmetry suggested that Atlas had either been shaped under controlled conditions or maintained through ongoing regulation. Emotion entered the analysis as quiet wonder, because Atlas challenged the assumption that geometry at this scale must arise from blind processes alone. The structures did not announce themselves dramatically, and Atlas avoided sharp edges or reflective glare that might draw attention prematurely. This restraint suggested subtlety, as though Atlas concealed complexity beneath an unassuming exterior. When surface maps were layered temporally, Atlas showed no evidence of erosion that would degrade geometric integrity, implying durability beyond expectation. The absence of random fracture lines further distinguished Atlas from natural bodies subjected to micrometeoroid bombardment. Researchers noted that Atlas behaved more like an engineered surface, optimized for longevity, than like exposed rock shaped by chance. This observation did not force conclusions about origin, but Atlas narrowed the range of plausible explanations considerably. If artificial processes were involved, Atlas demonstrated a philosophy of construction that prioritized stability and efficiency over visual dominance. The geometry appeared utilitarian, and Atlas expressed function through form without excess. Such efficiency resonated with earlier observations of controlled growth and motion, linking structure to behavior. Emotion remained measured because Atlas did not threaten with its design, but invited contemplation of purpose embedded in material. The patterns did not resemble human engineering traditions, and Atlas avoided recognizable motifs that might suggest familiarity. Instead, Atlas occupied a space where design principles felt universal rather than cultural. This universality complicated interpretation because it removed anthropocentric bias while preserving the impression of intent. As analytical tools continued to probe the surface, Atlas resisted reduction to mere anomaly, presenting coherence across scales. The coherence suggested integration, where geometry, energy, and motion aligned within a single framework. Atlas thus transitioned from a subject of material analysis into a reference point for rethinking how artificiality might manifest beyond human context. The presence of geometric order did not resolve uncertainty, yet Atlas transformed uncertainty into structure rather than chaos. With this transformation, Atlas bridged physical evidence and interpretive restraint, carrying the narrative forward without demanding definitive labels. The next anomaly did not arrive through images or motion but through pattern, because at last began to register as a source of structured transmission rather than passive reflection. Radio observatories detected emissions that repeated with mathematical regularity, and as analysts filtered background noise, Atlas remained as the only consistent point of origin across frequencies. The signal did not resemble natural astrophysical processes, because Atlas produced sequences that aligned with prime numbers and harmonic ratios, forms long associated with intentional encoding. These sequences unfolded slowly, and Atlas transmitted without urgency, as though allowing ample time for recognition rather than demanding immediate response. When the signal was mapped spatially, Atlas appeared to focus its emissions toward specific regions of Earth rather than broadcasting isotropically into space. This directional quality suggested selectivity, because Atlas concentrated energy toward narrow bands that intersected with technologically active zones on the planet's surface. As the data accumulated, Atlas demonstrated consistency in targeting repeatedly aligning transmissions with areas associated with advanced instrumentation and signal detection. The pattern implied scanning rather than communication, because Atlas did not repeat content once acknowledgement could be inferred. This behavior challenged assumptions about messaging, as Atlas appeared to measure reception capability instead of conveying narrative or instruction. The mathematical structure of the signal remained simple in form yet precise in execution, avoiding complexity while ensuring unmistakable artificiality. Atlas did not escalate signal strength or frequency, and instead maintained a steady cadence that emphasized detection over persuasion. Emotion entered the analysis as restrained tension, because Atlas behaved like a system conducting assessment rather than outreach. The absence of linguistic content removed ambiguity, as Atlas relied on mathematics to bypass cultural interpretation entirely. This reliance reinforced the impression that Atlas was not attempting dialogue but evaluation. When the signal ceased, Atlas left behind no residual noise, and its silence felt deliberate rather than accidental. Researchers noted that Atlas resumed passive observation immediately after transmission, as though the scanning phase had concluded. The precision of the targeting suggested foreknowledge of Earth's technological footprint, because Atlas did not waste energy on unresponsive regions. This efficiency echoed earlier observations of controlled growth and motion, reinforcing the impression of systemic coherence. Atlas remained neutral in tone because the signal neither threatened nor reassured, and its neutrality carried greater weight than overt declaration. The realization that At Last could distinguish between regions of capability and inactivity reframed Earth not as a singular object but as a mosaic of development. This reframing introduced ethical reflection, because At Last appeared to observe capacity rather than intention. Emotions settled into quiet unease because At Last's attention felt impersonal, yet discerning. The signal did not demand action, and At Last offered no countdown or directive at this stage. Instead, At Last established context, defining Earth as a subject of measurement within a broader system. This definition altered the narrative trajectory because At Last now functioned as an external reference rather than an internal anomaly. The mathematical scanning thus served as a bridge connecting physical evidence to the hypothesis of oversight. Through this bridge, At Last transitioned from an object that behaved unusually to a system that gathered information with precision. As silence returned, At Last retained its position, and the absence of further transmission invited reflection rather than response. In that stillness, At Last completed a phase of inquiry, leaving the implications to unfold within human interpretation rather than within the signal itself. As hypotheses expanded beyond physics, researchers began to consider that At Last might be responding not to mass or energy alone, but to a threshold reached by the civilization it now observed. This idea did not emerge from speculation alone, because At Last appeared to activate complex behaviours only after humanity crossed measurable milestones in technological capability. The manipulation of quantum systems, the development of artificial intelligence, and the increasing ability to observe space-time itself formed a backdrop against which At Last's presence gained contextual meaning. In this framing, At Last was not triggered by curiosity, but by transition, because thresholds imply change rather than achievement. The hypothesis suggested that civilizations emit signals unintentionally through their actions, and At Last might be calibrated to recognize those signals once they exceed a critical level. Rather than responding to intention or morality, At Last appeared sensitive to capability because power alters consequence regardless of how it is applied. This sensitivity reframed maturity as a measurable condition, and At Last became a marker that distinguishes developmental phases rather than judging outcomes. The concept challenged anthropocentric views because At Last did not appear to care about culture, belief, or governance, but only about what a species can now affect. As this interpretation gained traction, At Last resembled a sensor embedded within a larger system, designed to register when influence expands beyond local boundaries. Such a system would not require constant engagement, and At Last demonstrated this by remaining dormant until relevant thresholds were crossed. Emotion entered this hypothesis as quiet introspection, because At Last shifted attention inward toward humanity's trajectory, rather than outward toward external threat. If maturity is defined by reach rather than wisdom, At Last may simply acknowledge that humanity has become visible in a way it never was before. This visibility carries no inherent judgment, because At Last did not accelerate or retreat in response to human behaviour, but only appeared to take notice. The idea of a maturity threshold suggested that At Last operates within a taxonomy of civilizations, each observed according to developmental markers. In such a framework, At Last would not intervene prematurely because observation before relevance would yield no meaningful data. This restraint aligns with At Last's measured behaviour because activation occurred only after sustained patterns of advancement became undeniable. The hypothesis does not imply inevitability, but it positions At Last as a passive gatekeeper that responds when conditions are met rather than when danger arises. Emotion remained subdued because At Last did not threaten regression or promise advancement and instead maintained neutrality. This neutrality implied that maturity is not a reward, but a state that brings consequences simply by existing. As researchers reflected on this possibility, At Last transformed from an anomaly into a mirror that reflects capability rather than intention. The mirror metaphor carried weight, because At Last offered no guidance, only presence. In recognizing a threshold, At Last may have done nothing more than acknowledge that humanity had entered a new category within a broader cosmic framework. This acknowledgement did not imply approval or condemnation, and At Last remained silent on outcomes. The silence reinforced the idea that maturity once reached speaks for itself through action rather than declaration. With this understanding, At Last bridged earlier physical anomalies to a civilizational context, reframing the narrative from disruption to recognition. The hypothesis gained additional depth when observational networks detected a second object approaching along a trajectory remarkably similar to that of At Last. This object, designated 3I Atlas b for continuity, followed the same interstellar vector, and its arrival timing suggested response rather than coincidence. The appearance of Atlas b did not introduce chaos because its motion remained measured and consistent, reinforcing the impression of coordinated behavior. When orbital projections were compared, Atlas b appeared to adjust its path in relation to Atlas, not independently of it. This relational movement suggested hierarchy or sequence, because Atlas b did not precede the original object, but followed it after key observational phases had concluded. Researchers noted that Atlas b exhibited greater mass and scale, and this disparity implied a supporting role rather than redundancy. The idea of reinforcement emerged cautiously, because Atlas b did not signal urgency, yet its presence expanded the scope of the system under consideration. If Atlas functioned as a probe or observer, Atlas b could represent a secondary stage designed to respond once sufficient data had been gathered. This sequence aligns with distributed systems where initial units assess conditions before larger structures commit resources. Emotion entered the analysis as subdued concern because Atlas b suggested that observation might transition into engagement even if no action was yet visible. The trajectory of Atlas b remained precise, and it avoided unnecessary proximity, maintaining a distance that preserved stability within the solar system. This restraint echoed earlier patterns associated with Atlas, reinforcing the perception of deliberate control rather than intrusion. Atlas b did not emit signals detectable at Earth, and its silence contrasted with the earlier scanning behavior attributed to Atlas. This contrast suggested functional differentiation, because Atlas b appeared designed to exist rather than to communicate. When simulations explored potential interaction scenarios, Atlas b consistently occupied positions that enhanced system resilience rather than dominance. The possibility emerged that Atlas b served as a stabilizing element, ensuring continuity should the primary object encounter unforeseen conditions. Such redundancy reflects engineering principles common to complex systems where failure is anticipated rather than ignored. Emotion remained restrained because Atlas b did not escalate tension, and instead broadened context. The presence of Atlas b reframed Atlas' arrival as part of a sequence rather than an isolated event. This sequence implied planning across timescales that exceed human immediacy, and Atlas b embodied patience rather than urgency. Researchers resisted framing Atlas b as threat or guardian, because its behavior supported neither role conclusively. Instead, Atlas b appeared as an extension of a process already underway, reinforcing the idea that observation unfolds in stages. The absence of aggressive motion suggested that Atlas b was not deployed in response to danger, but in response to confirmation. This confirmation may have arisen from data already gathered by Atlas, though the content of such data remains unknown. The arrival of Atlas b therefore expanded the narrative from single-object anomaly to multi-object system. This expansion did not resolve uncertainty, but it stabilized it, transforming mystery into structure. Through Atlas b, the hypothesis of oversight gained coherence because systems rarely operate with single points of failure. The reinforcement concept thus bridged observation and anticipation, allowing the narrative to progress without forcing premature conclusions. The final element of the hypothesis emerged not through motion or signal strength, but through time, because Atlas appeared to introduce a finite interval into an otherwise open-ended observation. Analysts noticed that the behaviors associated with Atlas aligned with a temporal framework, one that suggested progression rather than indefinite monitoring. This framework did not arrive as an explicit message, yet Atlas demonstrated sequencing that implied a bounded phase measured not in moments but in months. When observational milestones were arranged chronologically, Atlas revealed a pattern in which key activities clustered within a defined window, pointing toward an interval of approximately 390 days. This duration carried significance not because it marked an end, but because Atlas treated it as a complete cycle. The hypothesis proposed that Atlas operates on evaluative periods, during which data is gathered, conditions are assessed, and outcomes are determined without interruption. Such periods would require sufficient length to observe consistency rather than reaction, and Atlas appeared to allow enough time for patterns to emerge naturally. Emotion entered this interpretation as quiet pressure, because a defined interval transforms observation into anticipation without declaring consequence. Atlas did not signal urgency within the interval, and instead maintained stability, suggesting that the countdown reflected internal scheduling, rather than external threat. The notion of a temporal boundary reframed earlier anomalies because At Last's calm persistence now appeared purposeful rather than incidental. If the interval represents an assessment window, At Last would not require immediate response from humanity, only continued existence within observable parameters. This interpretation aligns with At Last's restraint because no attempt was made to influence behaviour directly. The countdown did not function as warning, and At Last avoided dramatic escalation that might distort natural development. Instead, At Last allowed time to unfold as it would, implying that authenticity rather than performance was the variable under observation. The presence of a finite interval introduced introspection, because time imposes meaning even when outcomes remain undefined. Atlas thus transformed duration into context, framing human activity within a larger temporal architecture. The interval did not demand acceleration or delay, and At Last remained indifferent to pace so long as continuity persisted. This indifference suggested that At Last measured state rather than progress, valuing what exists over what is attempted. Emotion settled into reflective calm because At Last's timeline did not compress possibility into panic. Instead, the countdown expanded awareness, allowing contemplation without forcing action. Researchers noted that At Last synchronized its own phases with the interval, reinforcing the impression of internal governance. This governance did not rely on enforcement because At Last neither constrained nor guided external behavior. The countdown therefore functioned as a boundary of observation rather than a deadline of judgment. As the interval progressed, At Last continued to observe with the same neutrality displayed since arrival. This neutrality suggested that outcomes would emerge from alignment rather than compliance. The awareness of time did not alter At Last's behavior, and At Last did not reward or penalize deviation. Instead, At Last held space for the interval to complete itself. Through this temporal framing, At Last closed the hypothesis not with conclusion, but with suspension.